Hello everyone. Nice to be a part of these insightful conversations about OpenTelemetry and observability. Today, I'll be talking about this particular projects, wonderful projects created by OpenTelemetry, which are the OpenTelemetry collector and OpenTelemetry collector contrib, which are both created by the OpenTelemetry organization. And I think that these projects can give you a really good head start if you want to monitor your infrastructures or applications. Let me start with my presentation over here. Also, let me introduce first myself. My name is Keval Bhogayata. I am a data collection engineer at Middleware. So we are an observability platform, and we do the same thing that I mentioned about myself. And how do I know about all this OpenTelemetry collector and similar projects? Because this is my day-to-day work. I do R&D on projects like OpenTelemetry collector, and there are some projects which are related to eBPF and OpenTelemetry simultaneously. So I also uh, read projects like Odigos and Pixie. I customize these projects and I make contributions back to the upstream projects. So I have made some bug fixes over there as well. And I create different distributions for all these projects. So I create daemon sets and Docker containers and all those things. So this is my regular work. I am familiar with OpenTelemetry collector for like the last 1.5 years. So let me share some of my insights, and I think that will be useful to all of us. So this is what my presentation will look like in the entirety. So first, we'll be starting from the topic of this meeting, the observability, and then we'll be taking a top-down approach from there. We'll be talking about two important domains over here: the infrastructure monitoring and the application monitoring. And then I'll talk about how OpenTelemetry Collector can help you in both of these domains. And also we'll talk about what kind of data OpenTelemetry Collector collects, what are different components of OpenTelemetry Collector. We'll see a short demo in my IDE, and at the end we'll discuss about is it really for you OpenTelemetry Collector, should you be using it, and we'll make some conclusions at the end. So let's get started. So as today we tried to define observability a few times, there can be a debate about the definition, but here I have simplified the observability in one line that observability is to monitor performance of an entity with like telemetry data like metrics, traces, logs, events, all those. And when I say an entity, I mean infrastructure and applications. When I say infrastructure, I not only mean like Windows, Linux, and Mac those systems. I also mean like hybrid infrastructures like Kubernetes and cloud platforms like AWS, Cloudflare, and all of those. And when I say application, I mean applications like JavaScript applications, Python applications, and all the major popular languages that are supported by OpenTelemetry these days. So mostly I'll be talking about infrastructure monitoring today, and at the end I'll talk a little about application monitoring. So yeah, infrastructure monitoring. So as I have observed that most of the observability platforms like Datadog, Splunk, New Relic middleware, everyone follow a particular blueprint while they monitor the infrastructure. And if you are monitoring your infrastructure as an individual, you should be doing the same to follow this blueprint. So what we generally do is we install an agent inside our infrastructure. It can be in a form of a Docker container or a daemon set. Then we expect that agent to scrape data out of our system. So it can be scraping our file systems, it can be reading our logs, it can be reading data from our network. And after once the data is scrapped, you expect the data to be in a particular format, because if you have a standardized format for your metrics data, then you will be able to make aggregations and you will able to visualize the data afterwards. So data formatting is also important. And once you format the data, you can store it in a time series data storage. Now if you are monitoring in real time, then the storage might not be important for you. But if you want to make weekly or monthly reports for your infrastructure and how it is performing over time, then you might need data storage. And the popular choices for time series data storage are Apache Pinot, ClickHouse, and MW delta leg. There are many options over there. And after the time series data storage, you might want to query the data that you have observed, and you might want to visualize them with platforms like Zipkin and Jaeger, like we just seen, and we can also create custom dashboards out of it. So this is, in my opinion, the common blueprint for a infrastructure monitoring. And out of these 5 steps, where I think OpenTelemetry Collector can contribute a lot is these 2 sections. So we'll talk more about those 2 sections in particular. So here you can see that OpenTelemetry Collector project is particularly dedicated to scrap the data out of your infrastructure. And the good thing is the collector also follows the OpenTelemetry semantic conventions for data formatting. And so you do not need to worry about the data formatting at all. All you need to worry about is use the existing data scraping logic, and you can customize and add your data scraping logic as well by customizing this project. But OpenTelemetry semantic conventions are interesting, and I might want to talk about a little bit about the semantic conventions, and then I'll move back to the OpenTelemetry collector. So why you should be having following the semantic conventions? Because it has defined some great rules for all kind of different pipelines. Like for metrics, they have some instrumentation types over there, like gauge, sum, histogram, and they have some rules about the data type. They have the rules for unit. So if you follow the rules and collect the metrics in that particular way, then you will be able to create wonderful graphs out of it, because you will be easily able to aggregate the data, and you can make graphs out of it with Grafana, Prometheus, and all those tools. And if you are working with traces and logs, then OpenTelemetry semantic conventions have some rules for including trace ID, span ID, parent span ID. So, and also the same goes for the logs. So you will be able to make relations between your traces and your logs. So semantic conventions are really good, and you should read the OpenTelemetry doc about the semantic conventions. They have rules for like Kubernetes and everything. So you should definitely check that out. But if you do not have much idea over here in the semantic conventions, then you can just use the OpenTelemetry collector, and it will take care of you about the data format by itself. So let's talk about how OpenTelemetry collector should be used in an architecture, and then we'll be seeing a demo of how it actually works. So, for example, let's say you are monitoring n number of infrastructures. So what you will need to do, you will need to install OpenTelemetry collector in each of your infrastructure, and each of that collector will be sending data to your backend server, where there will be one more collector running. So it will accept data from all those infrastructures, and this particular collector will send the data to a time series data storage or a visualization tool. So this is how the architecture looks like. In the demo, what I will do is I'll run the OpenTelemetry collector in my system itself, and I'll treat my system as backend as well. So here is the demo link. So even after the presentation, you can just go to this GitHub repo link, and you can see that there are 2 particular components over here: the collector agent and collector backend. So the first one is the OpenTelemetry collector, where I have made the configurations in a way so that it can work as a backend. And in the second portion, I have created the configurations to work as a backend. So let's get into the IDE, and let's look the projects in more depth. So the OpenTelemetry collector is mostly written in Go language, so you will be seeing the Go files here. And in both of these collectors, you will be seeing some boilerplate code that you will need to run the OpenTelemetry collector. So you do not need to worry about those boilerplate codes. You can just copy it from here or the original OpenTelemetry repository. But the thing I want to put your focus is about this particular configuration file. So this configuration file tells about all the settings, that what kind of data you want to collect, how you want to modify the data, and where you want to export the data. So all the rules are defined in this particular YAML file. So I will draw your focus over here. So these three are the most important components of the OpenTelemetry collector: the receivers, the processors, and the exporters. So we'll talk about them one by one. So yeah, the receivers. So receivers are the data scraping logic that is written in the OpenTelemetry collector repository. For each receiver, I have added the link for the documentation, so you can also check out the link and see what different setting it provides. So there are, if you go to the OpenTelemetry repository over here, the extension repository, and if you go to the receiver section, then you will see about 70 to 80 different receivers over here designed to collect data from different technologies. Like there is a Apache receiver, there is a Cloud Foundry receiver, Datadog receiver, and all those different things. So we can have all separate talk for just for the receivers. So because of the time constraint, we'll just be seeing two or three of these receivers, and then we'll move to the next component. So there are some interesting receivers that I want to talk about right now. That one of those is the host metric receiver. So this particular receiver is designed to collect data from your operating systems like Linux, Windows, and Mac. In Mac, the support is like building, but for the Linux, this is really stable. And once you use this receiver, then you get a lot of more options that what kind of data you want to collect. Do you want to collect the CPU data or the disk data, file system data, and all those things? So you can like create a turn on and off switches over here, and you can use it. And then we have the Docker states receiver. So this particular receiver can help you to monitor data of your containers, Docker containers running inside your system. You can see how many times they got restarted and what are their resource usage and all those things. So this is the another receiver I wanted to talk about. Then there is Prometheus receiver, so you can scrap any Prometheus endpoint, and you can collect data from that endpoint, and you can send to the backend your backend server. So these are so this is how mostly receivers work. They scrap the data for you, and you can use this data and pass to the next component of the OpenTelemetry collector. So once you have collected or scrapped the data, then next requirement you will have is to modify the data as per your need. So that's why we have processors. Here I will talk about a few processors. One of them is the resource detection processor. So what this particular processor does, let me show you another file to demonstrate this. Yeah. So let's say you are monitoring three different infrastructures, and all of those infrastructures are sending you the one particular metric, and you have no relation between your metrics and your system. So you are confused at which particular system is sending me this data. So once you use the resource detection processor, what it will do, it will add some resource attributes into your data. And so now you will have a clear relationship between your metrics and your resources. So you can create more relations between your data. So coming back to the list of the processors, that was the resource detection processor that we just talked about. Also, there is one resource processor which you can use to dynamically insert some key value pairs into your data if you want to bifurcate data coming from different sources. So this is how processor can help you out. So we talked about all these two. So once you have scrapped the data and you have also modified it as per your requirement, then next thing you will need is to export that data somewhere. So if you are just doing the development, you can just use the logging exporter, and you can see all the data in your terminal just going as the JSON format. And once you are confident that your data is ready, then you can send it to your required destination, maybe using a OTLP protocol, or maybe you can choose exporters from the large list that is given over here. So if you go to the exporter list over here, there are again like 70 to 80 different exporters. So you can go to them and you can choose any of them to export your data. So these were the main components. These were the main components of the OpenTelemetry collector that we just talked about. There is one another component called extension. This is not the part of the core pipeline, but using this extension, you can add some custom logic in your application. Like this is the health check extension, which can verify that your collector is running appropriately and it was up for a particular amount of time. So these were all the components, and now there is a service section where you can define all these what receivers you want to use for your metric pipeline and for your traces and logs pipeline. So you can define all the settings down here, and that is how the collector works. And let me run a collector for you over here to get a brief idea about it. Let's go to our SPOTcon demo, and let's get to the collector agent, and let me just start the agent. So once you get started, there will be logs coming over here, all the data you will be seeing over here, and I want to demonstrate the health check extension especially. So it shows you that the OpenTelemetry operator is running and the service is available. And as I have turned on the logging exporter, you are able to see that how much CPU my system is currently using. You are also getting the timestamp data so that you can relate the data in a time series data storage and all those stuff. So this was the agent collector. You can run the backend collector in the similar way. I have added all the instructions in the README file, so you can refer the project later. So this was all the things that I wanted to talk about the infrastructure monitoring part, and I wanted to talk about all the components. So as we seen in the demo, the receivers are the data scrapers, the processor is the data modifier, and the exporters are helpful for you to send the data to your data storage. And if you want to add some custom logics, then you have the extension. So this was all about the infrastructure monitoring, and now I want to uh, take your focus on the application monitoring. So when it comes to application monitoring, I particularly divide the applications in two major categories. First is the host-based category, and another one is the serverless applications. So when we are talking about the host-based applications, I am talking about applications which are running inside our local systems, which are running inside our EC2, inside our GCP machines. So those can be considered as the host-based application. But if you are working like with AWS Lambda functions or Cloudflare workers, where you do not have direct access to the infrastructure, all you need to worry about the applications. Then we call them the serverless applications. And for both of these applications, we use OpenTelemetry collector differently. So let's see the architecture for each of them one by one. So here is the architecture for instrumenting a host-based application. So here you can see that if you are already monitoring your infrastructure within OpenTelemetry collector, and let's say you are running a JavaScript application inside your infrastructure, then what you will need to do, you will have to install an npm package for OpenTelemetry collector inside your JavaScript application. This particular library will be sending data to your OpenTelemetry collector running inside your infrastructure, and this will be forwarding data again to your backend. So this is how the forwarding happens in a host-based application. But let's say you are running a serverless application like a Cloudflare worker, then your npm library will be sending data directly to your backend, and it will be further sending data to your storage and visualization platform. So this is how it works in both the platforms. The OpenTelemetry recommends that you use the host-based approach whenever possible, because if you have a infrastructure OpenTelemetry collector, then it will make a single stable connection, and it will be more resource optimal by the setting. But if you have no choice, you can directly send data from your library to your backend. So yeah, this was all about the application monitoring that I wanted to talk about. So I have also added some code for the application monitoring in my demo over here. So you can see that there is this Node.js application over here. Inside that, I have a simple Hello World API, and I have another tracing.js file. And what this particular file does is it has the code for instrumenting my JavaScript application. So if I run both of these files together, then my Hello World API will be monitored and will be seeing some good data for tracing. So we went in real depth in the previous demo of Jaeger about the application monitoring, but let me just show you a little bit about the application monitoring over here. Let me go to the demo and let me run this. So as you can see, I am running a simple Hello World API over here. And as soon as I trigger the API, my data instrumentation will start. And as you can see, I will get some events over here. I will get the trace ID, span ID, parent span ID, and all of as this is a single API, all of these entries will have a common trace ID, and you can create relations between the spans based on the span ID and parent span ID and all those things. So this is how application monitoring is also simplified with the OpenTelemetry collector. So yeah, so I talked about both the domains, and this is the time to make some conclusions over here. So why you should be using OpenTelemetry collector in your infrastructure or for your application, because it is a CNCF project and there is a large community which is supporting this project. Corporate developers like me or individual developers are also making contributions in this project from like last 2 or 3 years continuously. And if you want to talk about the future of OpenTelemetry collector, then I would say that there are some really interesting projects coming up there which are using the OpenTelemetry collector and eBPF technologies simultaneously, and they are instrumenting the applications really well. As I came across the word eBPF, I want to also take your focus backward over here, that when you are monitoring a host-based application, then developers many times complain that they do not want to modify their application code, and then do not want these much settings to do before instrumenting their applications. So what OTel plus eBPF based solutions do is they automatically instrument your applications with running a sidecar or something. But these solutions are more applicable when you are working with Kubernetes or hybrid infrastructures or microservices infrastructure like that. But these are really interesting domains to talk about. And is it for you? Is the OpenTelemetry collector you should be using or not? So first of all, I'll be saying that you will be getting a really good head start in data scraping, that you will not need to write code from, you do not need to like reinvent the wheel. You can get like 70 to 80 different libraries to scrap data from, and you will get a ready-made data format structure. You do not need to worry about how my JSON structure should look like if I collect metrics data or trace data or log data and so on. And but I would give a tip from the points I have written over here, that if you are running a small application which is like running one or two services, and you are running it in your local system, then adding OpenTelemetry collector can just create an overhead and it will not make sense over there. But if you are running any medium to large high latency applications, that I would recommend that you should be using OpenTelemetry collector and OpenTelemetry collector contrib. Both of these projects are amazing over there. At the end, I would like to say that me and my team at Middleware are working really hard about OpenTelemetry collector and all of those. We are customizing that project and we are using it really well. And we have created some really good stuff over here. So I will encourage all of you to visit the website or our product, and I will say that you can reach out to me on my work email or my personal email. I would like to talk about infrastructure monitoring and application monitoring, all the new projects coming up, all the open source projects. I'm ready to talk about it all. So I would say like that is all from my side. Thank you very much.